Alright, so in this video, we're going to look at problems involving waves, specifically transverse wave. So the first question is saying, waves are produced by a vibration of a frequency, and the frequency has been given to be 10 hertz, and the wavelength is actually 0.2 meters. Then A is saying, what is the period of the wave? So period of the wave, period is actually equal to 1 over the frequency, and period is actually denoted by capital T. So we write it that T is equal to 1 over the frequency. And looking at the data given, the frequency is actually 10 and we have the wavelength of 0.2 meters. So to find the frequency, we're going to plug 10 where we have frequency here. So we're going to have 1 over 10. And then punching this on the calculator, we're going to get a 0.1. So our period is actually 0.1 for the first question. And then part B is actually saying, what is the speed of the wave? So the speed of the wave, this is actually A, and I'm going to solve B from here. So the speed of the wave, same as velocity, is actually equal to the wavelength, which is denoted by lambda, times the frequency. So speed of the wave is equal to, the wavelength is actually 0.2 and the frequency is actually 10. So 0.2 times 10 is actually 2. So the speed of this given wave is actually what? Is actually 2 meters per second. And the period here is 0.1 seconds. Let us go to question 2. So question 2 is actually saying, waves travel at 30 meters per second through a certain medium. If 10 waves passes a certain point per second, find the frequency. So the data given, have here the data. So we have the speed, which is velocity, it's given as 30 meters per second. And the statement here is actually saying, if 10 waves passes a certain point per second, and if we go to the definition of frequency, we'll find that these are number of waves produced in a second passing through a certain point. So the 10 waves they are talking about, it's actually the frequency that we have. So this is the data given. And part A of the question is actually saying find the frequency. And frequency being the number of waves produced per second. So the frequency is actually the 10 waves that were produced in a second. So part A, frequency is actually 10 hertz, just like we wrote in the data here. And then part B is actually saying find the wavelength. Find the wavelength. So if we look at the formula for speed, we said speed is actually equal to the wavelength times frequency. So we just have to make the wavelength the subject of the formula, and we're going to have wavelength to be equal to speed over frequency, and the speed has been given as well as the frequency. So the wavelength is actually going to be, the speed is 30 over the frequency is actually what? Is actually 10. So the wavelength will be 3 meters. So this is our wavelength. So question 3 is actually saying, if 120 waves are produced per minute, so if 120 waves are produced per minute, find the frequency and the period. So part A is actually talking about what? Talking about the frequency. And the frequency, remember, it's actually the number of waves produced per second. So there we have been told that 120 waves are actually what? Are actually produced in a minute. So a minute actually has 60 seconds. So we're not going to write a minute, but we're going to write 60 seconds. So for us to find what our frequency is. So after writing this, we're going to ask ourselves now, how many waves are we going to have in 1 second? And then we solve for x. So solving for x, we're going to have 60x is actually equal to 120 divide by 60 divide by 60. So x is actually 2. So we're going to have 2 waves produced in 1 second. So therefore the frequency is actually what? 2 hertz. So this is our frequency. And then part B is actually talking about the period. And when finding the period, remember the formula is actually what? T is equal to 1 over the frequency. So period is equal to 1 over 2. So period D is actually equal to 0.5 seconds. So this is our period and this is our frequency. Let us look at question number 4. So on question 4, we have been given a diagram. So I'm going to draw a diagram. So we have this diagram. And the first question is actually saying find the number of waves. So if we look at how to find or to come up with the number of waves from the diagram, we just actually move from here, we reach here, we make half a wave. And if we also go down here and come back here, we make one complete wave. So this is actually 1, 2, 3, 4, 5. So this diagram actually has 5 waves. So part A, we have 5 waves. And then part B is actually asking to find the amplitude. So the amplitude is actually the distance from the origin to the crest here. So this is actually the distance, or from the origin to the trough here. So this distance is what we call the amplitude. So looking at this from here to here, or from here to here, we actually have about what? We have 5. So therefore the amplitude is actually going to be 5 meters. So for the amplitude we have 5 meters. So this is our amplitude. So part C is actually asking to find the wavelength. The wavelength is actually the distance that a single wave has. So if we move from here to here, this is one complete wave. So the distance from here to here is actually what we call the wavelength. So what is the wavelength in this diagram here? What we're going to do, we're actually going to write the number of waves that we have and the distance that we have. So looking at this, we actually found that we have how many waves? We have 5 waves. So we have 5 waves, and in these 5 waves that we have, they're actually having the distance of 6 meters. Yeah, this is what we have. 5 waves, they are having a distance of 6 meters. And remember, the wavelength is actually the distance that one wave has. So what would be the distance for one wave? And that is going to be our x. So we solve for x, we know the distance, or rather the wavelength. So we're going to cross multiply here, and we're going to have 5x is equal to 6. Divide both sides by 5, divide both sides by 5. X is actually equal to, so 6 divided by 5, that's 1.2 meters. So this is the wavelength. So the wavelength we have is 1.2 meters. And let us look at the last part, which is part D. So part D is saying find the speed of the wave if the number of waves in the diagram are produced in 6 seconds. So we have 5 waves here. So the question is saying what will be the speed if these 5 waves are actually produced in 2 seconds? And remember, speed, which is actually velocity, is equal to wavelength times the frequency. And the frequency is actually the number of waves produced in 1 second. So we already have our wavelength, so we're just going to find the frequency. So the assumption here is actually saying if these 5 waves, if the 5 waves are actually produced in how many? In 2 seconds. If 5 waves are produced in 2 seconds, what is the speed? But here we want to find what? We just want to find what the frequency is. And the frequency is actually the number of waves produced in a second. So we don't know the number of waves that are going to be produced in a second. So we have 1 here. So we're going to cross multiply to solve for x, which is going to be our frequency. And we are going to have 2x is equal to 5. Dividing both sides by 2, we're going to get 5 divided by 2. It's giving us a 2.5. So that is our frequency. So getting this and this, we plug it in the formula. We're going to have speed is equal to the wavelength is 1.2 times the frequency is 2.5. So the speed is equal to the speed is equal to 3 meters per second. So this is our speed. Let me write it here. 3 meters per second. So these are actually our solutions. See you in the next video.